Well, if a part-time pianist doesn't care about sound quality, who does? I've got to ask you that. Excuse me one moment here. I've got a bit of my own IT process to do. With this, we should have success. With this, we will have further success. Right. All right. So there's a lot of stuff happening in IP telecommunications these days, and you all are playing parts of this. One of the things that I think is going on, though, is there is so much happening in so many pieces of the industry that it's possible and pretty easy to lose track sometimes of what is the overall purpose for which we're doing this. What's the goal that we're trying to shoot for? There's so many small pieces that come in that they can obscure the major messages. So what I want to talk about today are backing off to some of the main points, the things that we're trying to shoot for ultimately. So what is the goal of human telecommunications? How has it been approached so far? What's happening now, and where are we heading in this world? So as we proceed, keep in mind there's some things that are not possible today that I'm going to be talking about. And what I would ask you is not to think that's not possible, but instead to be thinking, if it were possible, what could I do with it? Because that, I think, is where it gets really interesting. So let's talk about what the goal is. Now, we use a lot of words. We use, there are a lot of influences. We talk about visual. We talk about high definition. We talk about wireless, Zoom. But really, what this boils down to, what we and what our users are looking for ultimately, is the ability to be there now, wherever that is. And I want to talk about this in a little more detail because I think there is a lot of the pieces that we're continuing to work for are embodied in this very simple, very short statement. Let's start with B. We were just using the Kubler-Ross model. I think I can use B. What is B? What we're really ultimately going for is not just telephony. We're looking to capture and convey the entire physical experience. We're looking for the immediacy, for the fidelity, for the complete sense, the accuracy, that fast feedback. Put me there as though I was right here. I want that being their experience. And ultimately, there are a lot of pieces in this, but that's what we're looking for. Now, in order to implement this, what IP telephony has had to do, what we're all needing to do is obviously break it down into individual components. For example, we talk about presence, right? This has been just in the past few years, we've come up with the concepts of presence and status and reporting that. But ultimately, what we're looking for is we just want to have the same experience that we would have if we were in person. Presence and status are no different than me walking by your office, glancing in your window and saying, oh yeah, he's there, he's available, right? That's what we're looking for. So when we're implementing these things, we want to keep that in mind. Another terms we use, security. We talk about privacy. Really boil down to, is my stuff safe? And who's listening? So that's a big part. There are a lot more slices of B, but everything that we're doing is trying to come back to that, I can contact this person right now. That feeling that I could walk into their office and we could have the conversation, the being their experience. What is there? Well, usually in a conversation, we're talking about connecting two different places. So we're talking about linking geographical locations, which is my there and your there. But we're talking about more than that. Because I may be talking from a conference room, and you may be talking from a home office, and somebody else who's on the meeting may be talking from a cell phone under a tree. So we're not only linking our different enterprises, our different views of what this current meeting or conversation is, we're also trying to extract the part of this interaction that's most germane to what's going on. So you treat a train station different than you treat an office. You're ultimately wanting to talk to the person who's at the other end, probably not to the specific location where they are. And what you have for a network, what you have for the tools, the endpoints, all is playing a part in making the process of linking these things together transparent to the end users so they can connect, so that they can focus on the discussion that they're having, not on the tools that they need to learn and to use in order to make that happen. There's another aspect now to now, because my now is not your now. We're not only linking the theirs now, we also can be dealing with the time zone mismatch, right? At whatever time I was this morning, I may be doing something entirely different now. So we need to be able to accommodate the fact that people are at different stages of life, at different times of day, at different days of the week. It can go beyond the fact that I'm dressed for bed or I'm ready for a meeting. It can go into cultural mismatch. Because different cultures, different countries, different religions have different expectations on what happens on a Monday, what happens in the evening. We may have family obligations or mealtime. Mealtime may be sacrosanct. So this is another area that a connection that has no knowledge of what's going on, what the requirements are at each end, that can actually make a difficult situation worse. But a smart system can actually help ameliorate the mismatches that we will increasingly have in a globalized society. This takes us to what you could call being there-er. Because once you've got the connection, once you've got the ability to have a nice point-to-point conversation with somebody, you begin to assume that there's more available there than maybe. So we assume, for example, if we can talk together, we can understand. We must share a language. But in reality, if we're connecting all over the world, we don't necessarily share a single language. So this starts with possibly you and I have very different accents, and we have difficulty understanding each other, which is where HD voice comes in. But it can move past that to actually speaking different languages. And this is an opportunity, and I think to a fair extent, is going to be a growing need for the communication tool to be able to compensate for so that we can continue to have a meaningful conversation. Another part of being there is we assume we have a common shared experience. So a shared physical experience, I'm sure you've all had the experience, you're talking with somebody on the other end of the phone, and you're talking on about the presentation or the slides, and they say, "Excuse me, is there something on the wall that I should be seeing? Because this is a telephone and I can't actually see what you're talking about." Because you assumed, you're so comfortable that this conversation was going well, you forgot actually, Charlie can't see what I'm talking about. I got to do something about that. And then beyond that, you can also want or expect a shared experience, like, I got this thing, I'm going to pass it around. Why don't you see how it feels? It's got a nice touch to it. I think we should buy a bunch of these. So those are some parts of the sharing, the being there. And there's all the usual stuff that we expect, the PowerPoint presentations and the slides and the whiteboards and those sort of things. Once you've got all that, even if that's there, there's one more thing that you're expecting, and that's that it all works. That's sometimes not a definitely guaranteed thing. So what I'm going to do, I want to talk about this concept of being there and being therer. And I think one model that works well right now for dividing this up, to be able to cover what are some of the trends that have happened and are happening, is to take it in the respect of richness and access and accuracy, breadth, reliability, what these are. So accuracy, I'm going to define terms, don't worry. So accuracy is, the concept here is for whatever mode you're talking about, whether it's video or it's audio or whatever, how perfectly does the connection mirror what's happening at the source? So for example, as video moves from lower resolution to high definition, that's a step forward in what I'm calling accuracy. In richness, what we're talking about here is how much farther can that mode be extended. So for example, with video again, you could take your video connection, however good it is, and make it 3D. Whether that's a good thing to do or not, I'm not touching on right now, but that would be an example of richness. In breadth, this is talking about what other modes could be included. So for example, if you've already got video and you've got voice, what if you were to add a remote whiteboarding capability? That's adding what's characterized here as a breadth. And then beyond that are the probably more obvious ones. Access is how do we get to it. Reliability is how much can we trust it? Is it going to break? Is it going to work? Beyond the ability to be there now, to fully convey the connection, there are, of course, overlying guiding forces, as we just heard some discussion of. And there's a whole flock of these things, ranging from cost to internal and external regulations, to what our people want, to what the capabilities of the system actually are itself. But the right communication solution will benefit these constraints rather than work against them. And that's one way that you can characterize, hey, we're doing the right thing here. So let's talk a little bit with this background of what's happened so far in telecommunications. Okay, the very first step, what we had before we had anything else, was we had direct presence. This was getting to a meeting by physically moving ourselves there. Here you have what you might characterize as extremely high latency to initiate a connection. But once you get there, you have a real be there now experience because you are in fact there. That has certain restrictions, of course, although everybody who's here has done exactly that to be at this meeting. So what's happened next is that we developed the ability to extract symbolic representations of the interaction we wanted to have and put them in a communication of some sort. Again, you have extremely high latency. You have now much less information, but your own personal load for this is much lower, and the speed, the latency is generally, usually much less than it is by actually traveling there yourself. This gives way to ways of visual communication, symbolic visual communication. So here we have a visual semaphore, which, as electricity developed and the means were developed, turned into the electric telegraph. Now you've got a way of exchanging information almost instantaneously over long distances. However, your message bandwidth is very low. It is still highly symbolic. And yet it is through experimentation with telegraph technology, trying to develop technologies that would allow them to send multiple telegraph signals over a single wire, which turned into what they call the harmonic telegraph, which turned into what we call the telephone, that gave us the ability to now have untrained users exchanging live communications with one another. Once you've got this, just speaking in the audio area still, now you start to look at what is this meant for access. So initially telephones were installed, it was a business device. They were very expensive. It was between the bank and the stock exchange. But then farmers discovered this, and they found this was a good way to keep their families from going crazy out in the wilds of Nebraska. And they started buying telephones and connecting them together. They were using chain link fences. Sound quality was awful, but they could hear each other. Their wives could talk. Eventually, the phones became much more widespread. A lot of people didn't have their own phone, but they had the experience of being able to call someone with a payphone. Then phones penetrated the house, so the phone was right at your hand. Then we moved on into wireless. You didn't even have to be wired up any longer. And finally, we're now at a point where you don't even need a phone to make a phone call. You don't need a video conferencing system to make a video conferencing call. You don't need a special network because you can use the tools that you've already got. Video is another interesting development. This is a picture of what they thought video conferencing would be in 1910. One thing I've always enjoyed about this picture is the guy has his own IT department, if you notice there on the left. As of 1964, AT&T introduced the picture phone at the New York World's Fair. But the technology wasn't really ready for prime time. It required 3 coax lines. 2 of them had to be specially balanced. But technology didn't stop happening. It continued improving until where we are today is over standard networks, the ability to have immersive high-definition teleconferencing, telepresence. In the direction of accuracy, when we're talking about video, of course, we started black and white. Kind of what happened at our homes. We started black and white, we got color, we got high definition, we got big screen. And along with big screen, you should notice it made everybody happy. So now let's talk some about where IP communication is heading. But before I get into this, I want to spend one moment because we're going to be getting deeper into this question of how do you solve a problem that can't be solved, right? As we're starting to address things that don't exist today, we're getting into an area where we're going to state problems that there's no obvious solution for. My contention is the way you solve an intractable problem is you ask the right question. Because so often we will pose ourselves a challenge by stating a question and then dig right into what the answer to that is and start detailing out, laying out budgets and schedules and so forth, when really what we want to do is to step back and say, did we ask the question we really should be asking? For example, anti-gravity. The stated question is, how do you neutralize gravity? But the real question you should be asking is, how do I locally counteract gravity enough to achieve a stated goal? You apply the same approach to perpetual motion. Classic perpetual motion, I need a system that will give me more energy out than I put into it. Physics says you can't do that, but that's not really what you want. What you're really asking is, how do I get free or at least really cheap energy? And there is a solution to that. What you do is you build an enormous fusion power source in outer space, and you transmit the energy using wideband terahertz radiation to a receiving array of mirrors. We call it solar power. That energy is virtually free. The last case, of course, teleportation, this is the easy one. I want to build a Star Trek transporter, but really what I want is the benefit of being at the other place without having to go there. And all I need for that is a couple of endpoints and a network to connect them. So keep that sort of wide view of things as we go forward. Because it's going to be not only in what I'm talking today, but as you're continuing to go forward with all of the work that you guys are doing. That's important. Okay, where's IP communications heading? What's important is the perception. The added features and functions are only the means to the end that we're ultimately trying to get. They're not the ends themselves. So let's talk about accuracy. Specifically, I'm going to bring this down even farther to resolution. In the area of audio, HD voice, the move from 3 kilohertz bandwidth up to 7 to 14 to 20, this is happening already. And it's essential for accents, for realism. In the area of video, A comparable move has been happening from conventional video conferencing from SIF and standard definition up to high definition. Now, this is an interesting one because there are higher resolutions available, right? There's double high def, there's quad high def, but it turns out that 720p, 30 or 60, maybe 1080 really is kind of the sweet spot, because at normal viewing distances for the kinds of screens that people use, that is a good match to the resolution of the fovea of your own eyeball. So for normal widespread applications, we don't need to go to the double or quadruple resolution. We've gotten there. And that's why these are so popular in homes, because they are a good match for our home uses. We can push it beyond here, but in video, at this point, increasing resolution puts a significant increment, visible increment on network loading. It's much less, actually this is barely the case in audio. It turns out audio codecs are efficient enough that you can double voice resolution, the sound quality, without even touching the number of bits per second. We are not to that point yet in video. So generally, if you are at HD and you want to use your network bandwidth most efficiently, you're best off not to try and increase the resolution. You'll get smoother motion. You'll be happier with the results. Okay, let's talk about the richness. Richness has been a journey from the symbolic to the real, from the initial Western Union, the classic "Will you marry me" kind of telegram, to we've seen an intermediate point. There are weddings that have happened on Second Life, which turns out to be a bit efficient protocol, because you're just sending the descriptions of the motion. You're not sending the motions themselves. But these are all parts of the trajectory to the real being there kind of experience. Now, I don't know that you're anytime soon going to have this real an experience, but it's a nice goal to think about. But for richness, we can think about what are the tools that are available to achieve this. So in video, for example, we're already seeing a move to immersion. We see a capability of 3D video. I'm sort of on the fence as to whether that's really worthwhile for normal telecommunications or not, and it has limitations, but that's there. On the audio side, we have, as I said, HD voice. You've got multi-channel capability. And just your implementation tools that are available include things like implants and codecs and protocols and displays and transducers and all the different pieces that you can use to achieve these goals. I said implants. So I wanted to mention this because this is one of the things that I think we're going to be seeing certainly in the next 10, maybe through the next 5 years. The thing is, cochlear and retinal implants are already in use. Direct mind control has been demonstrated. Now, it's not nearly as glamorous as we thought it would be, but these things never are. Once you see how the magician does the trick, you're saying, oh, I could have done that. So the step to wider use is actually a real one. It's going to be driven by available technology, and each of us will be making a cost-performance judgment as these things become available. But given that people are having their eyes routinely operated on, given that people are doing facelifts and cosmetic surgery and sports surgery and so forth, I think the thought of, I would never implant anything in me is just a passing thought. And presented with a real opportunity, with a real benefit to it, I think it's going to be a very interesting world coming up. So the next piece that I want to talk about is just the breadth and the breadth of experience. These are things that we already have a pretty good understanding of. There are a lot of tools out there that we exchange from, we share information from point to point. The real key here is going to be having uniform, accessible standards. Because without that, you really don't get the widespread benefit. And then the last piece, to grow meaningfully, we need reliability. We talk different people talk about reliability in different ways, but we really do mean different things. We can be talking about packet drops. We can be talking about tools to analyze and patch problems. We can be talking about interoperability among protocols and networks. And these are all things that we need to have available to us. Think about what you go through when you drive a car. This is a real good example of a system that you're accustomed to steering. You have immediate visual feedback. You have an intuitive tool that you can use to correct its action, and you have visual feedback, very clear feedback of what happens as a result of that correction. That is a direction, an end that I think we need to get to in our own communication systems. So the last thing, the last of the five is access. There's a fundamental rule here that when communications goes IP, the whole network becomes transparent. And I think this is a very important one to keep in mind because it impacts everything that we're doing. It allows each network to talk across to another. This has been really the history of how most enterprise networks have been working. We developed independent networks for POS, for video and voice and data networking. And then what we did was we put them together, had them first share a common physical interface, and then we started to merge the protocols that they used on that interface. The only challenge that leaves then is that while this works well within an enterprise, enterprises cannot connect to each other. Enterprises, I'm talking service providers and carriers and anybody who has one of these islands. So the next major step that we need to be taking is the interconnectivity of these. Metcalfe's law, you're probably familiar with. It says the value of a system proportional to the square of the number of users. So the more users you have, the classic demonstration of this is the fax effect. Well, there is a corollary to that that says it's only the systems compatible with that benefit from that. So this is why we need to have the uniform standards. This is all pointing toward, as one goal, one point that's happening, is you work where you are. We're seeing all the pieces come together. High-capacity networks are coming into the house. You've got high-definition telepresence is now coming into the home. And you've got multiple platforms that can deliver these services. So I think the next few years are going to be very exciting for as we have increasingly globalized services and all of the new kinds of services that we're bringing. This is a pretty cool time to be. So I'd like to conclude with just what I think are the top five here. One is just to remember that IP transformation makes the whole network transparent. It means your phone system can exchange data with your laptop, with your video, with your home, with your kids, with your wife, with your work, and you can do anything that can be turned into data, which means virtually anything. The next is IP communications. The ultimate target is the richness of life. It's not a phone call. It is to everything that we experience when we're communicating with somebody at the other side. We want to be there now. The next, high-definition visual and voice is becoming ubiquitous. It's just happening. It's all over our houses. Anybody who has a media player that's got a phone capability, it's HD capable. You just need the network connection to achieve that. Fourth, reliability and ease of use are going to become increasingly important because it's not just going to be the nerds and the geeks who are needing to use this. I need my wife and my mom to be able to use this, and please help. And the last, you guys are the leaders in making this all happen. So I'm really pleased to be able to talk with you today. Thank you. Thank you, Rob.
Thank you.